All right, so we're part 2 here of solving systems of equations with substitution. So this is the last problem in the notes, and then I'm going to give you guys some other problems to work on after this. So they're having a dance party. 220 people are going. Both adults and children are going. $9 for the adult ticket, $6 for the child ticket. The school collects $1,614. How many adults and how many children attend the recital? Okay, so what are the two big ideas here? Two big ideas. There's people and tickets. Good. So tickets have to do with price, and people are people. They're physical amounts. You can't have like a half a person, stuff like this. Okay? So for the first one, the people, how many people are going? 220 people. So those 220 people, actually let's just fill in the two variables that we're going to use. What should we use for adult? A? What should we use for child? Okay, that's good. We got A and we got C. Okay, so A is the number of adults. C is the number of children. So then my question for you is, for the people, the 220 people, what does the 220 equal in total? So what do you do in total there? How do you do a total? Add, good. So what do we got here? A plus C, good. So that equation right there, you could never solve that equation because there's two variables and one number. So one equation, two variables, you can't solve that. Because you need to know how much A is so then you can get C, and vice versa. If you knew how much C was, then you could get A. Do you agree with that? So two variables, one equation, you can't solve that. So you need another equation. Two variables, two equations, you can solve that. So what's the other equation that has to do with ticket price? Good. 9 times A, that's the $9 for the adult, plus 6 times C. And what's that going to add up to? 1,614. So here's the system of equations. Two variables, two equations. This is something you can solve. All right. Which one of those equations looks simpler? The first one. So let's start with that. Start with the more simpler one. And I want you to isolate for one of the variables. So which one do you want to isolate for? You want to solve for C? Solve for C? Okay, so then how would we solve for C? Subtract what on both sides? Okay, so subtract A, and you have 220, take away A is C. So here's a formula for C. If I knew what A was, I could calculate C, no problem. So what do I have to do now? I got to use the other equation to help me with this. So where does this equation for C go? Right here. Right where you see this C. So now rewrite the second equation. 1,614 equals 9A plus 6C. But C is going to be written as 220 minus A. Now we have one equation, one variable. And that's what you need. You need to boil it down to one equation, one variable, so you can solve this thing. Okay, so the only thing that really kind of looks weird is this stuff on the right. So what happens when you have a number outside of a bracket like this? Okay, so you can distribute in. You got 1,614 equals 9a. 6 times 220, 1320. And then 6 times a negative a. Negative 6a. So solving equations, solving linear equations, you have to have the variables on one side and the numbers on the other. So subtract the 1320. And combine like terms. 9 apples take away 6 apples. Got 3a on the right. 1614 take away 1320. Just using my calculator, I got 294. 3 groups of something gives you 294. So divide by 3. So we got how many adults? 98 apples, 98 adults. So if we have 98 adults, how many children? 220, take away 98, 122 children. And then the verify step. Verify your solution. You have to plug them into both. So clearly 220 is 98 plus 122. This is a check. But the other equation, 1614 is 9 times 98 plus 6 times 122. And just double check that you got it right. 9 times 98 plus 6 times 122. Okay, you get 1614 is 1614. So this is the last question in the notes, but I'm going to ask you guys to grab some scrap paper and then we'll do some more questions. I have lots of paper up here if you need it. Okay, so you don't have this one, but you got some scrap paper, so just jot down the system. 2 equations. And then you look at the 2 equations. Which one do you think is simpler? So in my opinion, they're the same. Because why? This has a 1x, and this has a 1y. That's what you're looking for when I say simpler. You're looking for variables with only a 1 in front. So it doesn't matter which one you choose. It would actually be really easy to just isolate for x, hey? So isolating for x, what would go to the other side? The 4y. So what do you have on the other side? Negative 4y and a positive 17. So where does this expression for x have to go? Right here. Okay, so I'm going to let you guys try this. Okay, so we've subbed in our expression for x. timesing through by 2. So how many y's are on the left? All together, what coefficient would it be? Negative 9y. So that 34 has to move, right? To the other side as a minus 34. 7 minus 34. Negative 27. You guys get that negative 27? Okay, because you have to subtract 34, subtract 34. Okay, so now you have a negative number, 9, times by a variable, and get negative 27. So what does y have to be, positive or negative? Y has to be positive, because it's a negative times a positive to give you a negative. So what is 9 times what gives you 27? Okay, so y is 3. Once you know that y is 3, negative 4 times 3 plus 17, negative 12 plus 17, x looks like 5. You guys starting to get the hang of this? So this is called solving systems using substitution method. So in about a minute, I'm going to give you the next question. You guys can try. So I'll give you another easy one. Actually, I'll give you an easier one than this one. No, it won't have any of those nasty fractions or anything. The fractions one? I haven't decided yet. So easy is a relative term. So like, it might be easy for you to do a layup. It might be hard for others. Because you're a basketball player. Okay, y equals x plus 2. And 3, there you go. 3x plus 4y equals 1. Okay, so give that one a try. Okay, second equation. This x plus 2 here is going to get subbed in where we see y. So second equation, 3x plus 4y, but y is that thing in yellow, x plus 2. You've gotten used to now this distribution. 3x plus 4x plus 8 equals 1. 7x plus 8 equals 1. How to solve that? Get the numbers on one side, variable on the other. So move this plus 8. Where does he got to go? Other side. See how that plus 8 moved? 1 take away 8. Negative 7. So how do you change 7 to negative 7? What do you got to times by? 7. Ah! 7 stays to 7. So it's going to be 1, right? But how do you make a negative 1? Times by a negative 1. So then if x is negative 1, here's the formula for y. Negative 1 plus 2. Y is also 1. But it's positive. Good. So remember, when you solve these, you're solving for both an x and a y. So it's always, the solution is always a coordinate pair. Just remember that. The solution is always a coordinate pair. Okay, you want another simple one like that? Okay, and this one you're going to solve all by yourself. I'm not even going to help you. Here's another example of a system that would be deemed easier. Why? X is already given with an explicit expression. Like, they're telling you exactly what x is. X is this expression. So then in the other formula, I can replace x with that expression. Okay, good. So a lot of people were getting this 2y plus 10 and the 5y plus 4. Some of you who probably listened to me and said you substitute in with brackets, that might mess you up a bit. You're like, oh, what the heck? Well, those brackets, you don't actually need them because you're not timesing this x by anything. So altogether, you have 7y and 14. And I just want you to think about this equation. Like, think about this equation. You have to go something plus 14 is 0. What does this something have to be? This has to be negative 14 plus 14 to get. So what does y have to be to make this negative 14? So negative 2. And then once you have that y is negative 2, and a lot of people got there, you just throw it right here. And then you go 2 times negative 2, negative 4 plus 10, 6. So the answer is 6 comma negative 2. This is the answer up in the top. So how many people got that on their own? Okay, so we're looking at about almost 2/3 of the class. Okay, so now we're going to level up the difficulty here. We're going to level up the difficulty. Oh, this one I'm looking at has fractions. Oh my gosh, how are we going to get away from not doing fractions? Okay, hopefully this one doesn't have fractions. 4p plus q and 7p plus 4q. Okay, give this one a try. So the first step, hopefully you're able to do this on your own. Q is the same as a negative 4p. And where are you going to put that value? Wherever you see Q. Okay, stay focused. So subbing in, you have 7p plus 4 times minus 4p. That all equals 3. So 7p minus 16p. 7 minus 16 is negative 9p. Now this is where, how many of you think p is 3? How do you multiply 9 by something to get to 3? You'd have to times it by a fraction. I didn't know it was going to be a fraction. Okay, and then once you have p, you can go up here and solve for q. Minus 4 times minus 1/3, and you get 4/3. Because you only times top by top, bottom by bottom. So this one only had fractions till the end, so that was okay, right? It was not for us. Okay, so this one here, possibly. This one here will have a little bit of a weird outcome. So I'm going to leave it at that. I want you to try it, and then we'll talk about the results. Okay, yeah, you guys are getting some weird results. So you threw this here, yeah? So I get 2 times 3y plus 2 minus 6y. So you got 6y plus 4 minus 6y. These cancel, and then you get 4 equals 5, which we know is not possible. 4 does not equal 5. So what did we just show? We broke math. This is a contradiction. Do you agree? Therefore, the original assumption was false. Okay, so for the first one, x plus 3 x equals 3y plus 2. What do you have to do with this to get it into mx plus b form? Subtract 2, then what? Divide by 3. So what's the slope? 1 over 3. So check the other equation. See if the other equation has slope 1 over 3. What's the other equation? 2x minus 6y equals 5. We have to check if this has a slope of 1/3. So what do we got? That's kind of ugly. Okay, so what do we have to do with this one? Take the 6y to the other side and bring the 5 over. Now what do we divide by? 6. Is 2 over 6 the same as 1 over 3? So they have the same slope but a different y-intercept. So same slope but different y-intercept. So that's going to happen. We'll talk more about that over the break, after the break. Yeah, we can do math over the break. That'd be fun. So again, we'll talk more about when you have no solution after the break. Okay, so I'm going to give you guys some time to work on your own.